I wonder who had this idea about talking about all this?
So because we have only 45 minutes, the idea of this session is to come back to the basics of big data. Just we are going to talk about the basic, the foundation of Hadoop. We are going to talk about Hadoop, Hive, Spark, and Kafka. Okay?
Yeah, Sorry. Basically, I said we want to do a presentation that I always wanted to hear. I always wanted to hear the basics of big data. Like, don't show me all this. Give me the 4 most important technologies, and tell me how it's working. And then, of course, is it working in the cloud? So this is the kind of thing we want to achieve, to give you a good understanding about the 4 most important technologies, and to show you how this is working in the Oracle Big Data Cloud. And I'm very happy to have a colleague here. Can you introduce yourself?
Yes, sure. Okay. So my name is Edelweiss Kammerman. So the name is quite complicated. So everybody call me Edel, which is much more simple. So I'm a computer engineer. I am director in BI. I usually participate in international conferences as a speaker. I'm from Uruguay, and we have the Oracle user group, an Oracle user group in Uruguay, which I run with some of my friends. And if you are wondering, where is Uruguay? It's right there, between Argentina and Brazil. So we have the ocean right there in front of us. It's very nice. In summer, in winter it's kind of cold. So this is the main square, and our airport likes like a mothership, but it's a very nice one. Okay. So, what about you?
Frank Munz is my name. Actually, my very first paid job ever was being a data scientist, although at that time the word data scientist didn't even exist. I was still working on a PhD and working with a group that was doing brain research. My boss was a neurologist, and obviously he knew about brains now, and he also knew about motivation. And I remember really well the second day I started, he said, "Frank, come on, do you have a minute? I want to show you something." And he showed me this colorful picture of the brain surface, and he said, "There's only one group in the whole world that is able to calculate such a picture, and they're very useful because they show the function of the brain and not just the structure." And he said, "We have a lot of patients, like small children, that suffer from epilepsy, and sometimes we can treat them with medication, but very often they stop responding to this medication. And then there is a possibility of doing surgery, but the surgeon obviously doesn't really know where to cut now, and he needs to understand about the function of the brain at this location." And he said, "We cannot calculate those images." And obviously he knew that I was like really keen on solving this problem. And finally we solved it with a technology that is even more low level and more complicated than the very first one we're going to present you in 2 minutes. So these days my job is maybe a little bit less dramatic, but not less exciting. I work in the intersection of, using classical Oracle Fusion middleware, open source tools. I wrote a book about clouds in 2011, another one about WebLogic in combination with these open source things a bit later, different clouds. I became a developer champion that helps a little bit to promote this intersection of new technology, open source, and the classical Oracle things. Now, Edelweiss is really lucky because she lives, I think, very close to the sea. How far away is it?
In front of.
In front of the sea. I am so jealous because I'm based in Munich, and Munich is like, I don't know, at least 600-800 kilometers away from the sea. But you know what is very special about Munich? And it's not the Oktoberfest, not the big beer party that we're having right now. And I'm still here. It is, we have surfers in the middle of the city. That's the fun fact of Munich. So whenever I nip out for a coffee, I see people passing by with their surfboard under their arm. And they go surfing in a river that is flowing through the English Garden, through the biggest park that we have. There's a steady wave behind one of the bridges. It's a well-known spot, so people even from Australia come and bring their surfboard and they surf there. So they just go from left to right, and then after 2 minutes, the others, they knock on their board, and that's the signal for them to go away. We want to surf now. And it's one of the very few spots in the world where you can do this. Right, so we start with the first technology that we want to present, and it's Hadoop.
Yeah.
And it's the task of Edelweiss.
Yeah.
Now, I tell you what, we decided about those technologies, and she's going to present about Hadoop. But maybe half a year ago, I was in a meetup at the Google office in Munich, and they said, well, Hadoop, MapReduce, they were talking about this as well. And one guy said, we're not doing any MapReduce anymore. So just to not only tell you the good things, also to give you a little bit about the trade-offs, is it still worth talking about it? Or should we just skip it?
Yes, and I will show you how.
Okay, I'm really interested.
Okay, so but first of all, let's go to an introduction of what is big data. No? So if you Google it, you will see a lot of definitions, but we can base it in 3 Bs. Okay, so volume, we are handling a huge volume of data. And variety is not one structured data, it's completely raw data, unstructured or semi-structured. Velocity, the way that we can receive the data, we can consume and do something with it is very fast. Okay, so for example, typical thing of big data, all the weblogs, Facebook, all the media that we just receive all the time. So for example, right now, how many tweets do you see in this conference? No? So Oracle added another business definition, which is value. So you have big data, you have what they call it, the data lake, but sometimes you need to be sure that there's some value in this data. And this is the most complicated thing, find value in all this huge amount of data that you have. Okay? If you Google it, you will have definition with 7, 8 Bs. So it's people are just being creative. Okay, we're going to talk about Oracle Big Data Cloud Compute Edition. So this is a big data platform which is integrated with Oracle, with open tools, open source. So it's almost ready to use it. You create a cluster and that's it. That big platform is already integrated with all the open source tools and also with other PaaS services as Database Cloud, MySQL Cloud, Event Hub, so you can also configure the security access, data access, network security, and you have REST access to all the functionality that you have in this big data cloud compute. Okay? So this is an image. We are going to show a deep demo of how do you work with it. So you have this is the main page, the main cluster console. When you have all the things to monitor, we're going to talk about it. Okay, and one thing that we are going to use a lot in this session is the notebook. So we have some very interesting integration with Apache Zeppelin notebook in this compute cloud. You can interact with the data very easily. It has something that is called interpreters. So you have different blocks, and then you can use this log with different language. So for example, like I have one block, like this one, for example. Okay, I can have one block for just a shell, just using Unix. Another with using a script, Spark, for example, Spark shell, or Hive. So we are going to see all of that. But coming back to Hadoop, is this worthy to talk about it? Yes, of course. So Hadoop consists in 2 parts mainly. The HFDS, which is a file system when we are going to store the data, and the MapReduce, which is the way that we can have to access the data, just to do some queries in some way and find out which is the information. Okay? So Hadoop is been here for a long time. A lot of the Oracle big data products are based on Hadoop, so that is why it's also important. And manage huge volumes of data, is highly scalable, and it's also cheap. You can have like 1,000 of nodes in a very cheap accommodation server, so you don't need a huge big data appliance, to have Hadoop. Okay, it will process in parallel very large data sets. So yes, it is still worthy. The way that usually you access the data is with MapReduce, but right now we are using another stuff. But Hadoop, the HDFS, is still very worthy. Okay, so we have some kind of video. I think that there is a comic, a cartoon by Bargeny, which is really good. He's an expert of big data, but he also is kind of a good drawer. Yeah, because he's created a very nice cartoon about it. So let me show you. So the idea is that you have a client, a name node, and a data node. Okay, so let me. And after that, the register is okay, perfect. Okay, so I split the size, the file, replicate the replication factor. We have then the client divide the file into this size, into the block of this size. Okay, say the register to write the first block first, and said, okay, you have this node, this node, this node to write it. Okay, the client send the data to the first node, and after that, meanwhile, Iris is receiving the data, it replicates in the second, and the second is replicated to the third one. After everything is gone, they send a message to the register that everything is gone. And you have to do, the client will do that for all the blocks that consist the file, okay? So in order to read it, just access the register node, and the register node send information on which block it's in which data node. The client will access the data node that is closer to the client, okay? And that's it. It's quite simple, okay? So the way that you read usually with Hadoop is using MapReduce. MapReduce is the block programming part of Hadoop, okay? So you have a map method and a reduce method. The map method is going to do is filter and sorting and receiving the key value inputs. And the reduce method summarize that key value and provide them other mappers. This can be done in Perl, in Python, or in Java. So for example, the MapReduce example that we have, for example, one file that has these 3 rows, imagine, okay? So we are going to do an example with simple 3 rows. So the first thing that it has to do is split. It split every single row in different parts. After that, we have the process will be map, will be the enter for the mapping. So it has 1 dog, 1 cat, 1 rat. It counts all the words. This is the process that we're going to do in example, okay? So it does exactly the same for the split. Remember that we have 1 file, 1 big file, and then split it into blocks. These are the different blocks. Then the mapping, it counts the words. And then then the process will shuffling it, so that all the dogs appear together, the words that contain words. So after that, the reduce process, which will be, is exactly that. Reduce the content and count that, okay, they have 2 dogs, 3 cars, 2 cats. And then it go all together to the final result. Okay, this is an example. This will be also in the so I think it will for the next time I just show the document. It will be better than that, but well.
Okay.
Okay. So let me. Okay. So this is the code. This is Java code. Just the packages that we need, classes that we need, and then we have the map method, okay? Just receive the string and count it. And then the reducer just will receive this entry from the mappers and count, okay? Okay, so let's talk about Hive.
Is it Hive next? Yeah,
Yes.
It's Hive next. But Hive is, I don't want to frustrate you more, but Hive, I always hear about Hive, and then people tell me, first you explain HDFS, and we go away from the relational databases, and you tell me we have those cheap disks, and it works on a cluster of computers. And then usually when I hear about Hive, people tell me they introduce tables in SQL again.
Yeah.
And that's
Yeah,
very
it's true.
confusing, no? First we go away from the database, and then you tell me
Yes.
we come back.
But there's a good reason because
Can you explain this?
Yeah, sure.
Oh, cool.
There's a good reason for doing this.
Cool.
There's 2 main reasons.
Okay.
One, because all of us knows a lot SQL, right? We have been here in this world for some time, and we all know how to program in SQL. So this is a language that is very important for us. So you don't have to learn a new language to access the data that you have in Hadoop. And another important thing, that's a lot of analytic tools need this structure to can reach the data. So for example, Oracle BI, ODI, or another analytic tools, in fact, there is one very nice that is big data discovery, sorry. These tools needs Hive to read Hadoop with the structure of the table, okay?
I see.
So yeah, it's quite interesting. So Hive, what it offers is an open source data. In fact, it's a data warehouse software over Apache Hadoop. Okay, so you can create it, structure the data into tables, and you can query like it's like Hive SQL is almost common SQL. You have also procedural language, HPL SQL. Okay, and all the metadata that is created with this transformation of the Hadoop data into tables. All the metadata is stored in a relational database, okay? So we're going to see a demo, a live demo, which is simpler. So I want to show you the cloud. It's in Chrome, right?
It's the Chrome, yeah.
Perfect. So this is the main page once you enter into the Oracle Cloud Compute Service. And then you press here, and you go to the Big Data Cluster Console. Okay.
So big data is provisioned already? The service itself is provisioned already?
No, you need to create it.
Okay.
So you need to create it. And one important thing, you can use some cloud trials. Okay, so if you want to, you have a trial with some credits. Be aware that if you're not using Event Hub, I think with one node, it will be more enough than just to play with it. But if you use 3 nodes, all your credits are going in just 1 day or 2 days, okay? So try to use 1 node just to play with it, and that will be okay. So you need to create a cluster. You need to select also the type of version of Spark that you are going to use, and you decide the amount of nodes and CPUs and all that stuff, okay? So this is the main page, which is like a monitor of the. Let me try to. Okay, and then you will have the notebook. The notebook is based on Apache Zeppelin. It's the version that is using right now is 07. So we have, for example, some demonstrations here, and we're going to use one of them to show you how to manage Hadoop in Hive. So the notebook, the possibility that it has is you can use the interpreters. Okay, you can say which type of technology you are going to use for this particular block. So in this case, I'm going to use Hive. Okay, so in this particular version, to use Hive, you need to use JDBC interpreter. Okay, so you are going to see in some blog posts that previous version used %Hive directly. Okay, it's not working anymore. You need to use JDBC. Okay, in this case, what I'm going to do is to load information in a Hive table, okay, and show you some graph. Okay, in order to this thing works, I will drop the table in case it exists. Okay, so I already did it. It's very fast, and I create another block. And you can put a title here. You can also play it all. Okay, and for example, here you don't see the code. You can click here, and the code will appear. Okay. So in this case, I'm going to load data into HDFS. The first thing that I have to do is also upload the data into my local system in the cluster. Okay. So that is why I will use curl. And this is a zip file with the insurance of Florida that I found out in the internet. Okay. So you can use that. You can also upload information from your computer. I'm going to show you how. Because this is a zip file, I will unzip it. And after I have it in my temp directory in the cluster, I will put it into the Hadoop, okay, into HDFS. With this simple line, I put it in there. Okay, I'm checking the temp folder just to be sure that it's there. Okay, perfect. And then I will create the Hive table. So this is a create table, you know, SQL. It's created. I will load the data, okay, from this path from the HDFS into the table that I just created, okay, and just query the data, just a simple select. Okay, and you can change that for a table, okay, and it's simply that, okay. And the nice thing of the notebook is that you can have all these things recorded, so you can create a lot of process that you want, or maybe have different type of visualization of your data in the same page, like a dashboard, okay? It's quite cool, okay? Perfect. So next, come back to the slides.
Now I see why we need tables again.
Yes, it's important, you see? Okay. So right now we're going to talk about Spark. So Spark.
Spark, yeah.
About Spark, okay.
Yeah.
So I don't know, if you're already accessing data using MapReduce, why do we have to use Spark? What is the benefit of using it?
Didn't we agree you just ask simple questions? Yeah. Why Spark? It's a very good question. What Edelweiss explained, the MapReduce, it seemed very generic, no? You always implement a map function, then you implement a reduce function. Sometimes there's several layers of this. So it's very generic on the one hand side, and it's actually also very robust because the whole MapReduce is writing and persisting basically for every single step a file on disk. So there's a lot of disk I/O. And those seemingly benefits like being very generic and being very robust is also the biggest disadvantage of MapReduce. First of all, I would say it's not a very refreshing programming model if you have to implement map and reduce and map and reduce. You can do it if there's a really important use case and you have no other solution. But it's probably not what you want to do every day. And the other thing is all this persistence with the disk I/O. You might say, well, we need this because it could crash at some point of time, and the idea of having all these temporary files obviously is that you can start up at any point again, and it's really no problem in HDFS and MapReduce if you take out one node, if you disconnect it from the network, if you disconnect it from the power. All this is kind of built in. But still, there is a better solution, and the better solution is Spark. And Spark does it in memory. That's the whole thing. So Spark tries to do as many computation in memory. This is why it's orders of magnitudes faster. You can imagine if you avoid all the disk I/O, you're just much faster if you do this in memory. It's not a Java framework, as some people might think, so it's not like Spring or so. You can really use it and program in Scala, Java, Python. You can run it standalone if you want on your laptop, if it's big enough for a small Hello World example. Or you can run it in Hadoop, and that's the other thing of Hadoop. This is why my question about do we really still need Hadoop was a bit unfair, because Hadoop is still used to run Spark jobs. Or other cluster systems like Mesos is getting more and more popular, can also be used to run Spark jobs. And also the principle is the same. The MapReduce kind of tries to get the computing to the data and not the other way around. So the data is distributed and then we process the data locally. So some people say Spark is kind of the new MapReduce. But just imagine we had all these other technologies on the first slide. So there are other possibilities, and one of them, for example, is Apache Storm. Now, if you start coding a little bit with Spark, those RDDs, they're called RDDs, and that's one takeaway from this Spark section. They become your very best friend because it's the data structure that we use to interact, that we use to write Spark code. There is a newer version, it's called data frame or data set, but basically, for the purpose of this presentation, let's just treat it as all the same. So we need those RDDs, and the question is, where do we get those RDDs from? How do we construct such an RDD? First of all, the question is maybe what is it really? It's short form for resilient distributed data set. And what it means, it's robust again. And now you wonder, I just told you that we don't persist to disk all the time. We keep it in memory. How can it be robust? Well, it can be robust the same way as you have other things in memory that don't disappear if one server crashes. Just think about what we do in, let's say, application servers with your session. That could be a HTTP session that contains your shopping cart that is automatically replicated. So it's like a distributed shared memory programming model, if you want to see it like this. This is also where the distributed comes from. So it's automatically distributed. We don't need to distribute this data set. And it's a generic data set. And that's super cool. That means basically you can load a JSON file, you can load a table, you can load a text file. And this is also the first way how to create such an RDD. You just read in something from HDFS from your local file system. It could be from S3, from the Simple Storage Service from Amazon. The other way to do it, and that's more programmatic, you have an existing collection, maybe in Python, and you parallelize it. You can parallelize a normal Python collection into an RDD, or you can transform one. The thing is, you can transform one RDD into another RDD, but you cannot change the RDD itself. So it's kind of immutable. And now, of course, we need to understand how to work with these RDDs. And again, I think the principles of Spark, you can kind of understand really in 5 minutes if you just take the key takeaways. And the principle to work with Spark is that we apply a number of transformations. This is what you see on the left-hand side. It's the green box. In all these transformations, well, it's functions that you know from Java 8. No, it's map and flat map and things like this. They're all applied one after the other, but nothing happens. And that's kind of the secret of Spark. It just kind of concatenates these. And then the last one is an action. And when we apply the action, something happens. So the question in Spark always is what happens in the driver, in the code that is executed locally, and what happens distributed. And of course, all this computation will happen distributed, but it happens with a lazy evaluation. So all these transformations, they are calculated when you apply the action at the end. So if you do a collect and you want all your data back, the transformations will be applied. Or if you do a count, or if you do a first. And I want to do a small demo using as well the big data compute instance that Edelweiss was already showing. And we are also, that's just a recording, I'm not showing this. And we're also using those notebooks, those Zeppelin notebooks. Let me see if I can find mine. It's actually really good technology. I was doing a whole Spark course based on these Zeppelin notebooks where you have something pre-filled and you try and complete this. So I highly recommend if you plan to work with HDFS, with Spark, with Hive, to use this technology. Now what we do here, and let me zoom in a little bit, is we start with a shell notebook. And well, honestly, what we're really doing here is not big data because it's not big enough, but we just pretend to do big data. So what I'm getting for you is a data set that contains the whole work of Shakespeare. So it feels a little bit like big data, no? When did you analyze the whole work of Shakespeare? A while ago, I guess, if at all. So what happens is I get it, I write it to HDFS, HDFS put writes it to HDFS, I delete the local file, and then I do this echo done, and the shift return is kind of executing this, and you see, well, it is very, very fast. It's downloading, and it says done. This is it. Now, if I do an ls and I execute this again, it will show you that we, in fact, have this file, which is this s.txt. Then I read it in. Remember, I told you could get an RDD by reading in a file. And this is exactly what happens here. There is a Spark context that is implicit if you use a Python Spark notebook. So we take the SC, the Spark context, read in the file, and we get this T. And the T contains, well, the whole work of Shakespeare. And what I want to see is the first line. And actually, the first line looks a little bit funny because it's not only the work of Shakespeare. There is a preamble that is kind of describing the way you can use this ASCII data and so on. So this is why we have some, a funny first line, okay? Let's check if the T really is a RDD. Let me execute this, and you see it's a map partitions RDD. So I'm not lying to you, it's really an RDD. And now this next part is where the real magic comes in. Who could program a lambda function of you, just for curiosity? 1, 2, 3, that's good. I was showing something very similar at the German user group last year at the conference, and there was a group of 20 students, and not anybody raised his hand, so I was kind of surprised. At least you should be able to read it. Okay, I tell you what happens here, and remember we do these transformations that basically do nothing first of all, and then they're executed when we apply a action. Now we first take the RDD and we apply a flat map, and the flat map uses a lambda function which defines, well, what is happening with the flat map. Later we use a map. Now what's the difference between flat map and map? If you say flat map, you apply this function that you specify here to every item of the data set. But you expect that for every item you apply it, you get a return which is more than one item, like 2 or 3. So basically we split the line, we look for a space character, and you can imagine if you split one line, you get a couple of words back. Then the next one, it's one-to-one, it's map. For every input, for every word that we have, we convert this word into a tuple. So for every word, if the word is like green, we make it green, 1. So every word is converted into this tuple. And then, at the end, we reduce those tuples, and we say by key. So if there's 1, if we have green, 1 and green, 1, we reduce it by the key. The 1 is the key. And for 1 and 1, we would make 2. So for A and B, we would replace it by A plus B. And this is kind of word count in Spark. And obviously, I should run this. Let's see. And this went really fast. And now I expect to have a lot of tuples that say something like, well, green, 3, and red, 5, and all the other words that Shakespeare was using with the number of counts as often as it occurs in Shakespeare. And what I'm doing here is I want to see them, so I want to retrieve them, but I want to retrieve them from the one that occurs most often to the lowest one. This is why I say, well, give me the first 10, and this is why I negate the key, because this is the easier way I can get the one with the highest ranking first. And as you see, the first one, I have to admit I was not really good in cleaning up the data. I get this empty thing, which is also some lesson learned. A lot of big data is cleaning up the data first, and the naive approach of just applying our algorithms often doesn't work. But then you see I have the word the very often used in Shakespeare, like 23,000 times, followed by the word I, followed by the word and, followed by the word to. All this makes a lot of sense. Now, you'd be very surprised if the word green or yellow would occur here as the most frequently used. Actually, we can check for green. Look at this. Green is like 52 times. Red is like, what do you think? Less, 47 times. But it's Shakespeare. He's not writing about green and yellow like we IT people think. What is he writing about? How about hate? 114 times. It's more than green and yellow, no? How about love? The opposite. What do you think? 1,200 times. A very positive guy, I would say. The analysis of Shakespeare by an IT person. Let's check for love, let's check for hate. What I did first is what I thought I'll check for algorithm to make sure it's doing the right thing. And nothing, that's good. So Shakespeare was not writing about algorithms. But you see what's happening, and you see how we apply those notebooks and how useful they are. Basically, what I could do is I could register this RDD as a table. And this is sometimes working, sometimes it doesn't. I'll just tell you this right ahead. If I say describe table, what I did is I added the columns like W for word and C for count. So I have W and C, it's a string and a big integer. And now I want to execute the SQL, which basically says, well, give me the words and the count from the table, order it by the count, descending, and the first 15 ones. And again, you see this huge number of nothing where probably just see the line breaks and other things. And you see the words again. I can visualize this. This is the part that is often not working. Here I did it already. So this is the visualization. This is all the bad data that I have in the not a number. And I shouldn't do this, no. So if you visualize it, one cool trick is you can just make it go away now, and then you have your real data. The other thing that I didn't do, and if you've done this yourself, you probably realize, how about the capitalization? We are counting words like and with a capital A different than and with a lower a. So all this has to be to lower and so on. But I think you get the basic point about using Spark. It's done in memory, it caches results, it's a flexible programming model. Well, the criticism that I had before I started using it is that very often, especially in those small examples, we combine everything that happens. Where is it? Like here, we combine everything in one long line. So the code is really short, but to write this long line, it's rather complicated. Resembles a little bit like to Scala code, in my opinion. Good. How are we doing time-wise? Let me check. 6 minutes, okay, that's challenging. I'm gonna give you a quick introduction then into the fourth technology that we wanted to talk about, and it's actually Kafka, which is not really big data, it's more fast data. And we had a lot of amazingly good presentations here about Kafka, so I'm just gonna give you a quick overview and tell you what you can do with Kafka in the Oracle Cloud. And it's actually not the big data compute service that does Kafka. There's a special PaaS service in the Oracle Cloud. It's called Event Hub that is doing Kafka. And so some people...
This is not like Shimia's messaging that we have been doing like 15 or 20 years. This is like a cool trend. If you want to be a cool geek, you need to use Kafka, something like that.
You keep asking those difficult questions. Actually, I think I was just hearing a presentation where they said, you know, in Kafka, this thing, the Kafka topic, it's like a table in the database. And I thought like, no, I don't really disagree. There's this kind of duality of Kafka topics and tables that we have, but it's a very abstracted way of looking into this. And if you start with Kafka, I think you should first of all look at it as a messaging system, no, like WebLogic JMS or like some other messaging system. And then the interesting thing with Kafka is that the producer appends at the end, obviously, and that this append operation for the producer, if you write something to Kafka, it has a constant overhead. So it doesn't matter if you've written 5 bytes, 5 gigabyte, or 5 terabyte, writing something to Kafka is quick, and it doesn't matter of how much data you have already written. There's really nice performance graphs about this. The other thing that is really different to a normal messaging system is that if you read a message like those consumers, they read it with an offset. If the message is read, it's not taken out of the Kafka topic. So it stays in the topic, which is good because if you want, you can reread it. Now the Kafka system stores the position of the last message that you have read, and 2 different consumers can read at a different location. And the other thing is that it's partitioned. So I've seen a lot of projects where they did the implementation, but then at the end they didn't really understand about the partitioning and about the replication. So one good question about every Kafka project is how do you partition and how do you replicate and why? No? So the partitioning that we do is we split one topic across different brokers. The different brokers are on different machines typically, and we do this. Why? Well, we do it to distribute the load, to distribute the messages. If the throughput is per broker, it's kind of multiplied, so we reduce any throughput issues, and we increase concurrency because we can write at the same time. There's something else which is called replication, and the replication is done, well, for other reasons, and can you guess why? The replication is done because one such topic like A1 could fail, and the question is, where's our data? And if you want to compare it to messaging, like to the WebLogic messaging that we have for the whole Fusion middleware stack, we don't do this. No, we don't replicate a distributed queue to another instance. In WebLogic, if this topic A1 would fail, it would be restarted on the same machine. It cannot be restarted on the same machine, that it would be migrated to another machine. So the Kafka mechanism is different. It replicates onto another broker. So we have replication, we have partitioning, and we should configure both, and we should know how to configure them. And they have a different purpose. And the third thing that makes Kafka a little bit challenging is that we have this extra thing that is called Zookeeper that is used to store state. So at the beginning, the state where such a consumer was reading already, what was the offset of a consumer, was stored in this Zookeeper process. This has changed now. It still has the functionality of keeping state in a distributed way. And a producer can ask the Zookeeper system how to connect to a particular topic, where this topic is located. Maybe I give you a very small, that's a good question. No, I think we just skipped the demo. It doesn't really make sense. There is one very popular example, and I kind of recommend you to get the slides and to read. The New York Times was doing something that goes towards what I told you about this duality, that there is a duality between Kafka streams and tables. So the New York Times, they took one Kafka topic, which is one partition only, so no magic, and they write with different producers into one topic, and they read with different consumers from this topic. Now this topic, the messages, as I told you, if you read the messages, they are not deleted. Typically there is an expiration date, which is default 7 days, but they also disable this expiration date. So they keep the messages there forever. And if you think about this, they use it more like a database table. And the cool thing is that they can add more different clients here. And they keep all the publishing that they did since 1850 something is in one single Kafka topic. And if they add a new client here, the client can read about all the publishing that was done for New York Times. If you have a client that is already reading from last week, it could continue to read from last week. So this is kind of integration technology more. This is more where Kafka is used as a table. And just to stay in time, there's different clients for Kafka. One is a Java client that I wanted to show you. I'm going to show you. I still have 1 minute. Should show some Java code at least at Java 1. That's a Java client. This is all that is needed to write a message to Kafka. So there's some setup properties where we basically need to tell the system how to talk to Kafka. This is Kafka Event Hub running, as an Event Hub service in the Oracle Cloud. And what I do is I write like 3 messages or like 13 messages. I create a producer, send it. The producer sends it. You can specify the partition you want to send it, hard-code it, which is probably not so good. You can supply a key, then it's using the key to hash the key and distribute the data. Or you don't specify even a key, and then the data is sent in a load balancing way. And if I execute this, it's running, and it should print like those asterisks, and you see it's printing like 13 asterisks. Now the cloud service looks very similar to what Edelweiss was showing for the big data service. You provision a Kafka cluster, then you provision a topic. Then the biggest thing that happens typically to people, and I've seen a posting from a really good colleague who said like, oh, I couldn't access it. You can't access it because it's kind of in the cloud and there are ports which are closed. So what you need to do, and this is maybe my last slide for Kafka, and then we conclude. What you need to do is you need to open ports. Here we go. There is a port for Kafka itself, and then there's a port for Zookeeper. And depending on what kind of tool you want to use, you need to open those ports. It's not difficult. You go to the instance, you go to access rule, and open them. But it's also not really well documented. So before using external tools, you need to be aware that this instance is in the cloud and that you should open those ports. I think with this we conclude and we jump to the end. If you have very little time, and this is kind of the summary, too long didn't read, I think this open source technology is a really good way to get started. What Edelweiss is doing with all the advanced Oracle tools, where you get all the cool graphics and all the stories behind the data. But I think you should know the basics now to get started. So I recommend to learn them first. If you go to the cloud, and we were trying to show this with the big data instance and with the notebooks, you have lower setup times. We had some struggle with the licensees and with the resource usage, no?
That is why I told you, don't create a very big cluster, because it will consume everything in just a couple of hours. So try to keep it one node, just to play with it and start working with it, with the cloud trial, and then you will see. Yeah.
I agree.
I think that is the best. Otherwise, everything will be blocked in just a couple of hours. So
exactly.
you don't want it.
I think in total it's maybe slightly more different than it seemed here. So I recommend to either go to a hands-on workshop, maybe here at Open World Java 1 if you can. Or the other thing is, it's the cloud. It should start up in a few minutes, and then people should be able to demo something. So talk to your friendly Oracle sales consultant and say, no, don't show me PowerPoints. Don't show me a provisioned, generated demo that other people were doing. Show me something live, hands-on, like what we were doing. So all the code we were showing was basically you can copy and paste it and redo it yourself. And if we had like 2 hours, we could just type it. And again, I think those notebooks are really, really cool. I used them for a Spark training. And anytime I would go this way. If you think, this professional software run this way? No, in big data cloud service, you can just submit a Spark job and then it's executed at the background. Well, we upload the slides. You can contact me. You can hire me if you want. You can contact Edelweiss. This is her Twitter data. And at the end, we would like to thank the Oracle ACE program.
Yes, and if you are interested,
making this possible.
Yes, and if you're interested, we both are Oracle ACE directors, and there is a program that if you collaborate with the community, writing blog posts or writing a book or going to the conference of user groups or something like that, you can be into the Oracle ACE program. So you can just go to that link and try to be part of this.
Right, so last sentence, sign up for a cloud trial. Make sure you don't hit the resource limits and code something amazing. Thank you, bye.
Bye-bye, thank you.